Our last lesson is on periodicity, and we have actually covered a lot of this. Back when we covered electron configurations, I brought in some of this because I thought it makes electron configurations easier. In particular, the part that we did with the S block, D block, P block, F block, to get the configurations, that normally is put into a chapter in a book on periodicity. So again, I think that helped with our electron configuration understanding. It's a lot easier than using that off-ball diagram, I thought, to get those configurations. Anyway, so we've already done a lot of this. I'm just going to kind of review a little bit because so that we can see some exceptions. I'm going to show you two exceptions to how we did that before. Those were the kind of predicted off-ball configurations, and so I'm going to show you what we would have predicted for copper and how we got it. And for copper, I'm going to do the noble gas abbreviation. Normally I would have gone all the way to the top and I would have started with 1s2, then I would say 2s2, 2p6, 3s2, 3p6, and so on. But I'm going to just back up to my noble gas argon, and then read from there. I'll say 4s2 and then 3d9. And of course I taught you that we should rearrange that. Because, so that we have the highest energy level off here on the right. Okay, well, it turns out that what's actually more stable is to have argon 3d10 4s1. So what's happening is that one of the electrons, I said 1 and wrote 2. One of the electrons here moved. One of the S electrons moved to the D shell. And the reason that it does that is there's something kind of stable with the D shell. If it's half full, which would be right here if it had 5, or if it's fully full, which would be in these columns where it would have 10. And so that shift from the S orbital can occur to make it slightly more stable. What's interesting is that if you remember, copper forms two ions. It forms +1 or +2. Well, the +2, if you have this configuration, like I said, both of these kind of exist. It's just that this one's slightly more stable. So if it's in this configuration, it loses its valence electrons. You get the +2. If it's in this configuration and it loses its valence electrons, you get the +1. Another exception to know, and there's just two, let's look at chromium. If we back up on chromium, we're going to have argon, and then I'm going to go ahead and put this in order. It will be 3d4, 4s2. And like I said, having 5 in the D block or in the D sublevel will make it a little more stable. So we'll have that same kind of rearrangement occur. And so what's most stable is this. So just know those two exceptions and kind of how they work. The next trend we've also already seen. It is just looking at a column on the periodic table and knowing the number of valence electrons. We know that in this first column they all have 1 electron in the s orbital, and so valence electrons, these, well, maybe I should draw that arrow further down, these all have 1 valence electron, these have 2, and then over here it continues with the noble gases having 8 valence electrons. And another thing we know, we've been calling a column a group, so that's true. But you need to also know that sometimes we call a group a family. Just another term for the same thing. There are several family names you need to know. This first column, those are the alkali metals. Next door, we have the alkali earth metals. Over here, we know these are the halogens. And then, of course, here, I saved gold because they think they're special. These are the noble gases. For each of these, there are some properties for them, and this little abbreviation for their configuration, the N, of course, is for energy level. All of the alkali metals have one electron in the s orbital and the highest energy level. So, like, this is just saying that because they're in this first position, they would have their electron configuration would end with 2s1, say, or 1s1, or so on. Anyway, know that they're very reactive, and they're more reactive as you go down on the periodic table. Metals are reactive if they give up electrons, and because as you go down on the periodic table, they're bigger, so their outside electrons are held less tightly because they're away from the nucleus, so they're more easily to be removed. But anyway, alkaline earth metals, the second column. Yeah, maybe I should put this on here. We always call these group 1, and we generally call these group 2. But anyway, they're not as reactive, but they are reactive. Halogens, you know, are diatomic. They do also all have a similar odor to bleach or like swimming pool, what we associate with a chlorine or Clorox kind of smell. And then, of course, you know, the noble gases are relatively stable.